Hello, everyone. Today we're going to be continuing our discussion of nomenclature by looking at naming benzene derivatives. So again, this means we're going to be looking at our good old friend, the aromatic ring. And so again, previously we're talking about looking at polyalkenes, so species with multiple double-double bonds. Well, one of the most special classes of polyalkenes are benzene rings. And again, due to its aromatic nature, it gets a special, unique behavior. It gets its own special name because again, resonance means it can push these double bonds all the way around. So these electrons are truly delocalized. So as a result, it won't follow the classic polyalkene names, but it will again borrow some of those similar rules. So again, the first important thing to remember is that a benzene ring can either act as the root name of a molecule, where it adds substituents to the benzene, or it can also, and this class of compound is known as benzene derivatives, so species that are derived from benzene. However, benzene can also act as a substituent. I can add a benzene ring to something, and these will follow slightly different rules. So let's go ahead and start by putting benzene at the core and look at benzene derivatives. So I can go ahead and name a benzene-containing compound using the following rules. So first, we're going to establish the root name. It's benzene. Now we need to work on the numbering system. So we're going to try and give the lowest locator number to each successive species. So in this case, I have so in my top case, I have three potential choices for giving that 1 to. The chloro, the nitro, or the ethyl. So in this case, I would have a choice of, if I start with the chloro, I'd have 1, 2, 3, 4. So I'd have positions at 1, 2, and 4. If I start with the nitro, this becomes a little harder. 1, 2, 5. If I start at the ethyl, it's 1, 3, 5. So chloro gets that lowest position. So what I can then do is start adding prefixes and locator numbers, same way as for alkanes. Because again, I'm not going to modify that root name. So that one chloro gets the 1 position, nitro gets the 2, the ethyl gets the 4. And from here, I'm going to go ahead and put them in alphabetical order. Chloro, ethyl, nitro, no matter what the numbering is. So again, we can apply the same rule for the second species. In this case, I have a nitro group and 2 propyl groups. So again, the one that will minimize the numbering is starting with the nitro, putting at the first propyl group at the 2, and the third one at the 4. So this becomes 1 nitro, 2, 4 dipropyl. Again, alphabetically, and comes before P, and then numbering follows. However, it is also, and that's more or less how we name our simple benzene derivatives. However, it is worth noting that in addition to these classic IUPAC names, di-substituted benzenes have an additional common name that is relatively highly used based on the relative position of the 2 substituents. So and so what we end up doing is we replace those numbering schemes with a simple prefix that tells us what the relative position of these 2 species are. So if our 2 species are in the 1, 2 positioning, as for this bromochloro species, I then go ahead and refer to that as ortho. So I can go ahead and either use an italics ortho before bromochloro, again, alphabetically, to say I have an ortho-bromochlorobenzene. Again, this really does help illustrate that while we give that lower numbering to the lower alphabetical species, that it really doesn't change that relative position and who's 1 or 2. However, we can also just shorthand that ortho to a simple O. However, you would still see me refer to that as ortho-bromochlorobenzene, even if only the O is written. Similarly, if I have a 1-3 position, this is called meta positioning. Same as the Facebook company. So at this point, it's going to be a 1-3 position. So this would normally be 1,3 dibromobenzene. However, I can simply replace this as meta-dibromobenzene, again, typically written in italics. Or just shortening it to M-dibromobenzene. And again, similarly, I have in this case a 1,4-dinitrobenzene. Well, I can replace that 1,4 naming with para. So this would be para-dinitrobenzene or just simply P-dinitrobenzene. However, if I'm going to go ahead and look as benzene as a substituent, now I need to essentially be attached to a larger carbon, a larger chain or carbon ring, or something that is more highly substituted, maybe something of a similar size, but now has a double bond, so that gets the priority, or multiple triple bonds. So in this case, the benzene ring is simply known as a phenyl substituent. So this can often just be written as simply putting pH to the bond connecting to the species. It is worth noting that phenyl rings are also frequently shorthanded as C6H5. So if you ever see me write down C6H5, know that I'm talking about a benzene ring, or again, a phenyl group. Now, what we can do is more or less just treat this like it was a cycloalkyl substituent to a larger chain. So again, if I'm looking at this species, I've got a 2-heptene. So again, 7-carbon long chain, double bond on the 2 position. This will get higher priority. So this ends up reducing my benzene ring to a simple phenyl substituent at the 3 position. So this becomes 3-phenyl hept 2-ene. However, there is another special subcategory known as the phenyl methyl groups. So this is where I have a benzene ring attached to a CH2 linker attached to the larger molecule. As you can see here, I have 2 of these phenyl methyl groups attached to a central cyclohexane. Now, these are also typically referred to as a benzyl substituent. So again, this would be a benzyl group. And these benzyl groups are also frequently shorthanded, again, as C6H5, but now with a CH2 in front of it. Or again, written as C6H5 linker or phenyl linker. However, if I go ahead and shorthand this as a benzyl, it can often make naming the system a little bit easier. So once I go ahead and do this, I can simply add that use that phenyl substituent as, again, more or less an alkyl substituent following the same naming systems. So I can shorthand this big molecule with 3 cyclic rings to a simple central cyclohexane ring with 2 substituents, making it much easier to name. So in this case, I can then identify that I have a cyclohexane root with 2 benzyl groups at the 1,4 position. So this big molecule now becomes 1,4-dibenzyl cyclohexane. Now we can again apply these rules for both benzyl derivatives and benzyl substituents to more complicated systems. So again, big trick is always first identifying that core ring or that core group. So on the left-hand case, again, our central motif here is that benzene. So that will form our core name. Now we have a chloro group and an ethyl group. So the chloro will go first. So this means I have a chloroethyl benzene. Now, paying attention to numbering, again, either way, I have a 1,3 scheme. So I'm going to put that 1 number on the chloro group. So this becomes 1-chloro 3-ethyl benzene. Or if I want to go a little simpler, a simple meta-chloroethyl benzene or an M-chloroethyl benzene. Now taking a look at the molecule on the right. So again, here, the big trick here is identifying that while the larger group is going to be the benzene, the more substituted group is going to be this polyalkyne on the left. So I can go ahead and simplify the system by changing that benzene to a simple phenyl group, at which point the naming is a lot easier. It's a 4-carbon chain with 2 alkynes, so it's a butadiene, or specifically but 1,4-1,3-diene. And then I can go ahead and either put that phenyl group at the 1 or 4 position. So easiest place to do is to put it at the 1 position. So I have 1 phenyl but 1,3 diene. So again, big trick. First, identify your root group, and more or less at this point you can follow a lot of the similar rules for benzene as for cyclohexane, and similarly for a phenyl or benzyl group, they'll follow very similar rules as if we were working with a alkyl substituent. All right. That brings us to the ends of playing with our alkenes and alkyne-based species. So until next time, take care.